Hello, my name is Pradeep Kumar, and I am your host and the Oregon Chapter Chair of the IEEE Communication Society. I'd like to welcome you all to the second in our virtual speaker series for 2020. Thank you all for joining us this evening to hear about an exciting emerging technology called CBRS. CBRS is an acronym for Citizen Band Radio Service. Each year, the IEEE Communication Society designates renowned communication technology experts to share their knowledge, expertise, and insights into the future of communication technologies. Our speaker today is among the distinguished speakers selected for 2020. Without further ado, I'd like to introduce our moderator, Dr. Rath Venathambi. He serves in our local ComSoc chapter. He has been instrumental in recruiting and lining up speakers and distinguished lecturers this year. In fact, we hosted Dr. Rath as a distinguished speaker himself at this forum in 2015. His talk at that time was about the evolving standards around 5G. Please welcome Dr. Rath Venathambi.
Thank you, Pradeep. You can hear me, right?
Yes.
Okay, all right. It is my pleasure to introduce my colleague and a good friend, Ra Yalla Pragada from Intel Corporation. He is part of Intel in California. It is really nice of him to give us a lecture on the topic that CBRS topic today. Um, uh, Ra has been is a program director of advanced technologies at Intel Corporation. His primary focus on new innovations in wireless communications. He's also in he has a, um, a distinguished career in product development and management. Current focus of RAW is in 5G based distributed computing and connectivity technologies, particularly targeted for various industry verticals. Um, Rao is currently serving as a vice chairman for board of the CBRS Alliance, as well as board of directors at 5G Americas. Prior uh, to work in Intel, he has been with Qualcomm Research Division, and he had several technical leadership positions in Qualcomm. He has worked on a wireless design, a wireless system design, and SoC product development. He had made significant contributions to technologies such as HSPA, LTE, 1X EV technologies, and the products ranging from all the way from the device modem as well as small cells base stations as well. Raw published several academic papers as well as holds several patents in wireless communications area. Raw received his PhD and master's in Dublin from Georgia Tech, and also an MBA from USC. With no further ado, I would like to invite Dr. Raw Jalapragda to tell us about CBRS.
Oh, great. Thank you very much, Rad. Thank you, for that nice introduction there, and thank you, Pradeep, and at Oregon chapter of IEEE ComSoc. Once again, I'm Rao at Intel Corporation. Recently I've been, working on the distributed connect and computing technologies, and I've been very much involved with CBRS from its very inception. I mean, I have this somewhat of a distinction that I was one of the founding members. I was instrumental to kind of having Intel to kind of found this organization along with Google and Google, Ruckus, Qualcomm, Ericsson, and a couple of others. Now it's a thriving 175 member organization, the CBRS Alliance. So let me kind of give you in an organized way, let me kind of pull up my charts and then kind of give you more about, CBRS Alliance, CBRS Standards, and then what's going on in this CBRS world. Okay, you can see my screen at this point.
Yes.
Okay, great. Okay, so today the whole idea, is to kind of present an overview on CBRS standards and commercialization of OnGo services. This is a great amount of interest in CBRS, and I'll give you the origins a little bit, and then why it's kind of important and what's really going on. There's a lot of interest besides the academic community. A lot of interest in hospitality industry, the stadiums and smart cities and enterprises and these kind of folks. And now, like I said, this Alliance, CBRS Alliance, was started in 2015-16 timeframe with 6 members. We founded the organization. Now it's 175, and you don't believe. I'm very much privy to the wireless ecosystem. The kind of names that you always hear: Qualcomm, Ericsson, Nokia, and these kind of guys. And now here in this 175, you hear names, all over the place. I mean, CBRE, for example, these are the kind of companies, Honeywell, and these are the companies who are kind of members of this one. So it's a very diverse group, meaningfully so. You have the wireless ecosystem, you have all these verticals. They're all kind of coming together, finding a reason to kind of be there, to kind of tap into this whole thing. So why this kind of interest? Okay, I mean, I'm sure some of you know what CBRS is, but I'll kind of start to kind of talk as if you were not much aware of it, because we have all kinds of audience who are into different kind of levels of expertise in different things. So CBRS is a 3.5 gigahertz spectrum domain. It's a spectrum domain which starts from 3.55 gigahertz or about 150 megahertz of spectrum and mid-band spectrum. And it so happened that this spectrum is being kind of underutilized. It's kind of given away to so military and been under and radar systems. Nobody's using the system, this very precious spectrum as much as it should be. You can imagine this is not the case in any other country. Okay, there are other problems in other countries, but in United States, this nice spectrum is underutilized. Okay, so now, so there was all this work that has been done by the industry, let me call it that way. All the members of various good organizations came together and then identified the spectrum and then try to find if there is a way to kind of make it more usable, meaningful, and then beneficial to everybody. That's what happened. And now we are here after 10 years of good work. We are here, and then there's been a lot of work going on here. And you will see as we go on, one could kind of deploy in this spectrum, just like the way you kind of deploy, systems in unlicensed spectrum. That's the beauty of it. There's a little more than that. You can also kind of get spectrum in a licensed fashion and kind of use the spectrum. So that's the reason you have a lot of interest, not only from fledgling new startups who want to kind of do things, versus companies like AT&T and then T-Mobile and these kind of folks who wants to kind of extend their current existing spectrum and then kind of deploy networks. That is the whole value proposition or the case behind CBRS. That's the reason there is a lot of interest here. So with that said, I'll kind of jump into my my organized presentation. Okay, and then kind of you can ask me questions. Pradeep pointed out how you can ask questions and all that stuff. And here is what I would say: you ask questions if it is anything compelling. It's a good idea to kind of take it toward the end if there's going to be a lot more discussion. But feel free to kind of ask any questions as I go. So some quick summary here, as to what I'm going to present. So this US CBRS 3.5 gigahertz band shared spectrum opportunity for broad wireless ecosystem from mobile operators, cable operators, MVNOs, neutral host providers, private networks, and the kind of folk that is very interested in this one. Now, CBRS Alliance is a industry organization that came around this Spectrum 3.5 to kind of develop the CBRS standards. Okay, and it also just like the Wi-Fi Alliance, which kind of developed, which came together for that Wi-Fi spectrum to kind of create, test and certification, and then the evangelization kind of wing to kind of promote CBRS. That's what CBRS Alliance is all about. Now, CBRS Alliance been working in a serious fashion for the last 5 to 6 years. It has organized itself. We the members, original members, and have created programs to kind of create CBRS technology specifications in parallel with 3GPP, not in conflict, in parallel. They are all kind of combined together, because this is an issue which is this 3.5 gigahertz issue is something related only to US. It's not to any other country because of the incumbency in the spectrum not being utilized. So we created these standards. These standards are relevant to United States only, okay, or anybody who wants to kind of participate in United States, so that sort of thing. So these standards, which have been there for the last 4 or 5 years, the standards body, and you see the same people, as in 3GPP standard, the same people that go to these standards, whether it is Qualcomm, Ericsson, Nokia, you name it. All these companies are here in CBRS Alliance to kind of create these standards. Today, they have released the version 3 of the standards. After going through release 1 and release 2, they're working on the release 4 at this point of time. And just to give an idea, CBRS release 3 aligns with the 3GPP release 15, okay, because the extensions or whatever that needs to happen to kind of ensure that systems can be developed and deployed, okay, along with 5G, for example, and which are kind of compatible with release 15. So release 3 is compatible with release 15 or consistent with that, and release 4 with release 16 and 17, just to give an idea of what's happening here. It's a very thriving ecosystem. As I will kind of present you some data, if I can, as I kind of move through my presentation in terms of the commercial deployments. And the first OnGo systems were kicked off in October 2019 after release 3 has been, I think release 3 was still going on, but with release 2 itself, the first systems were kicked off in 2019. Now, there's an important component, which of course I'll talk about it, a little more later. This is just a summary. I already alluded to it. There is a licensing component in it. They are called priority access license of this 3.5 gigahertz. These auctions started in, middle of this pandemic in, around July 20. It's kind of complete right now. So I'll give you more details about it, okay, as I go on. So that's just kind of the summary, but I'll give you a little more specific details. Brief history, I think it's important. Just be 1 second. I think what's happening is portion of it is being blocked. I will kind of, okay. So portion of my screen is blocked. Okay. So brief history. So 3.5 gigahertz, it's kind of almost the mid-band spectrum. People who are involved in 5G and then beyond, telecommunications, I think most of the ComSoc members, I'm sure, are following what's happening here in this world of 3GPP. So we have in US spectrum till 2.7, 2.8 gigahertz, and then we jump all the way to millimeter wave or centimeter wave spectrum, something like that. And we really don't have spectrum at play, okay, for 5G, in this range, so to speak, although there is a lot of work being happening in the C-band and otherwise. So 3.5 is a great opportunity as a mid-band spectrum. So when I said that things were launched, 5G system, the CBRS systems were launched. This was the first 5G systems in US were launched in the mid-band spectrum, early this year. Okay, so this 3.5 gigahertz, as a history goes, was identified by NTIA in 2010 as for possible use. And it took about, multiple years, as you can imagine, this whole spectrum business. Okay, so by end of 2012, something called Citizens Broadband Radio Service, CBRS, that's a name that they coined, and then they kind of proposed by FCC for investigation. How can we do, what can we do to kind of allocate the spectrum, make the best of it. Now, I did not give the whole story, but it's kind of trying to see where I can give you. This spectrum is used by military and radar, and grandfathered by some entities 100 years ago, not being utilized at all. If at all it was utilized by the military people, and they were using it for the incoming ships. Now the radar would kind of transmit on 3.5 gigahertz when they're approaching the coast of United States. Okay, and they are there for a few days, at the coast, and then they leave. Okay, now how many ships you think they are using it? There are 32 ships altogether using this 3.5 gigahertz spectrum at the coast. Most of the use is being done by these military ships, Department of Defense. 32 ships, United States coastline, you can understand, how minimal usage it was. So that was a situation, and and it's like a great real estate for 5G, private and private enterprises, and then public enterprises. It was one of the best kind of spectrum. They wanted to kind of use it. Okay, so a proposal was kind of finalized 2014, and a lot of different things happened 2015. When they kind of said how to kind of ensure that the spectrum can be shared by different parties. Okay, so they kind of put together some kind of a code, code, and then NPRM, that's what they issued it in April 2015. And multiple organizations came together, Wind Forum, which is a key one, to kind of see how this spectrum can be commercialized, basically. Okay, I mean, that's the right word, how to kind of put standards together, and then how to commercialize it. And then later on, CBRS Island scheme, that's where I think I was very involved, and then multiple others, of course, multiple other companies. And then there are like only one or two other people at Intel who are kind of very involved with it, to begin with. And they were, and mostly Intel is got involved in developing applications and products and all that stuff. So so that started happening 2016, and by 2019 November, we got the first systems done, and it's a lot happened here, in the last few years. And then you can also understand the spectrum is kind of has incumbents. Okay, not only military, Navy and radar, but it has incumbents who probably got the spectrum in middle of United States in some small pockets here and there. So it's kind of a messy kind of a situation, and to tell you the fact, all said and done, FCC wants to do something and DoD doesn't want to do, these are the kind of issues. And then companies want to do things in a different way. It's just like any other thing that we have done. It's just a very messy kind of an affair. But right now, the spectrum is all kind of allocated, and people are kind of now, a lot of work has been done. Products have been are getting deployed and being used. Okay, so this is the history, the best I can put it. Okay, and you probably some of you already probably know a little bit of what happened. So two organizations are key to this CBRS. Okay, standards and deployment and commercialization. So one is the wireless innovation, as I alluded to you briefly in my previous slide. Is a standards development organization. Basically, it's technology neutral. Very important to tell you that, because they, and they attracted, a lot of companies to kind of come together and see, what kind of requirements we can put together, basically for this purpose, how to kind of make use of this. By the way, CBRS, like I said, 3.55 to 3.7 gigahertz, right? So they're now looking into kind of adding some more spectrum to it, because there is a little more spectrum, below the band and above the band, that sort of thing, and see how we can kind of aggregate a little more spectrum, and then see if we can kind of make use of it. So as I kind of talk about it, but this whole thing kind of falls into this domain of shared spectrum kind of a situation here. So Wireless Innovation Forum kind of looked into this whole, is looking into, started to look into this requirements process, technology neutral, looking into how to kind of interoperate between, naturally this interoperation becomes a very important thing. So these are the kind of requirements it started kind of work. And it kind of developed a framework to kind of, work with FCC, how to do testing and certification, that sort of thing. Now, why CBRS Alliance? Now, when you talk about, hundreds of, I should not say 100, maybe, more than one kind of system, two systems, for example, let's kind of give me, you have LTE 3GPP systems, you have Wi-Fi, you have WiMAX, you have, now, 3GPP2 kind of systems in place. There may be one or two people, who will be doing, one technology versus most of the people doing, but you wanted an organization who are technically focused to kind of not just evangelizing, not just promoting, but kind of creating those technical elements in place for these technologies to make use of this 3.5. That's what we wanted to do. Once we realized what was happening in this WIN forum, it's Wireless Innovation Forum is nothing but, short form is WIN forum. We kind of came together. We means Qualcomm, Intel, Google, Ruckus, Federated Wireless, there's one more company it's kind of, so six companies came together and then formed this organization in 2016. So the idea was to, like I said, build the technology, the use cases, and then, figure out, how to kind of optimize the spectrum for use. That's what we kind of, that was the whole the mission behind the CBRS Alliance. So, so we kind of put together, the program to develop the standards. Now I kind of give you more about that one, okay? And the certification program, and naturally, how to kind of ensure interoperability, because nobody is kind of championing these kind of things, okay? Not Wireless Innovation Forum, not 3GPP, it could not be. This interoperation becomes a very important factor because, once you're kind of interoperating, coexisting together in this spectrum, okay, it's a shared spectrum, okay, to begin with. It's not like an independent spectrum. So this alliance has become more important to be, be there and then kind of, ensure that there is some order in place. So that's what is CBRS Alliance. Now, so as I begin, going into the technical details, so here is the spectrum, okay? So how it is kind of structured to begin with, okay? So 3.5 starts from 3.55 gigahertz to 3.7 gigahertz, okay? That's what this whole thing is. And the incumbents are like military radar ship, like I mentioned, and they're ship-based and then naturally ground-based at the coast, to receive and then communicate back to this military ships which are kind of approaching. And then there is a little bit of this fixed satellite service, okay? And now this is like in the middle of the United States in small pockets. And there are like wireless internet service providers who, once again, in small pockets here and there, grandfathered, 150 years ago, things of the name. I mean, this is the incumbents, and nobody's kind of willing to give up this spectrum. That was the situation when they came in. So naturally, we have to protect the incumbents, and that's the number one duty, once the spectrum is kind of given and agreed upon. So the way this got structured by FCC after all the deliberations and everything by 2014 when they issued the NPRM, that's what it's called. They said, okay, well, we'll have this tier 1 be protected, and they said, okay, let's kind of use, if incumbents are not using the spectrum, let's kind of allocate about 70 megahertz of spectrum in a licensed manner, meaning, one could license the spectrum. 70 megahertz of spectrum could be licensed. That's priority 2 or tier 2, but it's priority 2. If incumbents are not using it, about 70 megahertz of spectrum can be, is auctioned, and these auctions get priority to use. Okay, so that's a code that was kind of put in place. And the tier 3 is, let's say there is no PAL, okay, there's no priority access license then the entire 150 megahertz can be kind of given away. Anybody can kind of use in the spectrum, just like unlicensed spectrum where Wi-Fi is used. So this is the code that they kind of put in place. Now you see that for this is called the general authorized access. You can clearly see if this is 70, there is a minimum of 80 megahertz of spectrum that's been kind of given out for unlicensed spectrum. Okay, but 150 is available if no PAL is there. So you can almost imagine that 80 will be there, and as time goes on, PAL will be licensed, and most of the enterprises who wants to kind of buy into PAL will probably buy in counties where there are a lot of people, and then makes sense for them to kind of buy. So once you kind of go England into United States and where they're not rural areas and all, so you will have like 150 megahertz available all the time, but 80 megahertz will be available for unlicensed use. So there are lots of companies which kind of came together really to kind of deploy and then make use of this spectrum. Even scientists and companies which are kind of doing experimental work are using this, are kind of looking to kind of use this spectrum in the best possible fashion. That is the, once again, that's the attraction of this whole 3.5 gigahertz. So and one more important thing is, this is a complex problem if you're involved in this business. Okay, there is technology, there is there is policy, there is politics, and there is everything. So that's the reason this is kind of a little. So you have these kind of situations in Europe too, in Germany, in England, in Britain. You have these kind of issues, but and they did not want to kind of adopt something like this. They were just kind of waiting and watching as to how United States will address these things. They're looking for US leadership to kind of put things in place. So it took a long time really to kind of get, you saw the history, it took almost 10 years to kind of be here after kind of identifying and then kind of putting things together. So let me kind of take it up a little further. So we have three tiers here, as I said. So tier one is incumbents, like I said, the military radar, fixed satellite services. And then priority access is something that that is kind of auction, and then operators have license to this. And here, the use cases that you can kind of imagine is, these licenses will be are brought by enterprises who probably wants to who will be like T-Mobile and AT&T, who wants to kind of do carrier aggregation, for example. And there will be enterprises who wants to do so critical kind of services. They don't want to have any interference. They want to be protected in the spectrum. They want to have not only protection, but not even consistency, but some kind of confidence in kind of having spectrum to kind of use it. So that would be like, you can see healthcare services, and then some law enforcement, and then some other important kind of tasks. These enterprises will buy these licenses to kind of use this kind of spectrum. By the way, priority access is kind of granted. I'm not kind of giving you, I have like hundreds of slides on every small thing here, but I'm trying to kind of condense my conversation with you here. So priority access is 70 megahertz. It's kind of divided into 10 megahertz blocks. Okay, and it's kind of licensed on a county by county basis. For example, California has roughly 55, 56 counties. Each county, is kind of has a license, a CBRS license. It's not a statewide; it's a county-wide license. It's a large area, basically. So before that, so there is a little bit of history. So initially, in Obama's administration, when it was all identified, like in 2010, they said, hey, we will issue licenses based on sensor tracks, meaning the geographical areas in which these licenses are given is very, very small. For example, in United States, there are about 70,000 sensor tracks versus 3,500 roughly counties. So so as Trump's administration took over, and then of course there's a lot of lobbying happened, because you can imagine the very organizations like AT&T and T-Mobile, they really wanted not those sensor track kind of licenses. They wanted to have something much bigger so that their investments are protected. So there was some kind of a compromise, and now what you have is, these geographical areas which are larger than a sensor track county-based licenses, and they're kind of given for about 10 years. And each party can get up to, 40 megahertz which is 10 to 40 basically. So that way, I think the spectrum can be well utilized. And I mean, when I say utilized, there will be investment by big parties. Okay, so like AT&T and all that stuff. And at the same time, there are like enterprises and campuses, and you can imagine those kind of organizations can kind of buy into the spectrum and then kind of use it. Okay, so that's priority access. And you can see this pyramid here, and there is this general authorized access. There are plenty of companies which kind of came in here, just like the unlicensed spectrum, 150 megahertz. Now we are not using Wi-Fi. We are using something like LTE and 5G. You can see, I'm sure you heard, whoever is involved here today, participating, the difference, I would imagine, between LTE and Wi-Fi, or 5G and LTE. These cellular systems are kind of devised for harsh channel, and then, back and forth communications, and then ARQ kind of systems, those feedback loop kind of, engaged systems. So you have LTE kind of systems being deployed in 150 megahertz in unlicensed spectrum. It's something that that was a very valuable kind of a proposition for a lot of these companies who are kind of looking to kind of replace their DAS in venues and then use something like this. So this is the whole thing. So now this is all good for just sheer story and talk, but you can imagine the kind of complexity that was put in place. So you have incumbents, you have priority access, you have this general authorized access, and then you have 3GPP kind of system, non-3GPP kind of systems. Please imagine what we are talking about. So let's say if you want to kind of deploy 3GPP, you have all these sensory tracks, you have priority access. So basically, the current architecture that we have cannot be used here. What I mean by that current architecture means you have a end user device, and then you have a RAN, and then you have a network core, okay, or the evolved packet core. That's a system that you have. Okay, so that is not sufficient to kind of ensure that we can kind of provide spectrum and then harmoniously operate between all these different network users. So the architecture had to change, and that's where this whole idea of spectrum access system was kind of put in place, and I give you more details. So it's a one layer more on top of what we already have as far as 3GPP systems go. Okay, so that basically kind of provides or allocates spectrum. By the way, I'm not asking that I need a question, but the way that I am talking, I'm not seeing I am not seeing anything in terms of my chat. I mean, okay, you think? Sorry, I'm just asking this question. Are there any questions anybody has? If everything is okay,
since we don't have any questions in Q&A, maybe can I ask you a question?
Yeah, sure.
Yeah,
sure.
maybe you can tell a couple of things. One thing, recently you mentioned like, there were some like, auctions going on, and maybe you can say, like, I believe Verizon got some of the license and all. Maybe you can comment on it. And the second thing is, it'll be more interesting to see, like, the tier 2, it's more like a license kind of a spectrum.
Yeah.
And the tier 3 is more like a Wi-Fi kind of unlicensed kind of a spectrum. So where is the interest from industry in what kind of technology they want to put in tier 2 versus tier 3? What are the technologies are being developed? Maybe you can also comment on. Probably you're going to talk about it anyway.
Yeah, I'll quickly comment on it. Okay. So, like I said, for initially your question regarding these auctions are just complete. All the data is just coming out. Okay, so it has happened over the last 2 months or so. So we're getting more of the data, and then Verizon and AT&T participated heavily. Okay, and T-Mo also participated. So that's the thing. I don't have the granular detail who got what. Okay, at this point of time. But in regards to the interest in a system, you have Verizon's and AT&T's, and these are the people who are kind of using this system. And everybody, almost every company is interested to kind of use LTE and then 5G in all the tiers, in both the tiers, tier 2 and tier 3. Now, why so? So if Verizon is using it, they are definitely doing 5G, for example. Okay, so these are the big ones who are kind of doing it, and they can kind of depend on 3GPP to kind of provide the networks with proper standards, and then there is this ecosystem in place. That is another thing. Now, general authorized access is something that CBRS Alliance took up, and that's what I'm going to give you my talk on. Okay, I'm kind of running a little slow, looks like it. Okay, I'm going to speed up. But general authorized access is like lots of players, a lot of people who want to use it. So we kind of developed this whole LTE system in place, and now kind of moved on to 5G, and ensured all those enhancements in place so that we can kind of use these systems. So um, the one important reason is that when you have so many players who want to use it, they want to coexist together, as you can kind of clearly see. Different networks and then different e-node Bs coming together. They want to find a way to kind of get the optimal use of the spectrum, and also kind of be able to kind of coexist together with some with an order in place. Okay, so that's what CBRS Alliance has really done for general authorized access. Now it is kind of working towards ensuring how tier 2 and tier 3 can optimally kind of interwork together. That's what they are doing. So shall I kind of move on? Yeah.
Yes, please. Yeah.
Okay. So CBRS technology and specifications, as I gave you a little bit of an overview there. So here is the basic architecture here as I was talking to you. So basically, you can imagine that you have your regular system where you have end user device talking to your radioactive network and connected to the network core. So I did not kind of put my end user device here, but the end user device would be talking to your e-node Bs in the radioactive network. That's what this is, and then that would connect into your network core. But you can imagine that is not sufficient, like I said, because in a regular 3GPP system, that's what we have. Each operator has their own spectrum allocated to it, and they pretty much know that they can kind of use a system, and they're all pretty much okay, right? I mean, they can kind of access the radio. Users can access the radioactive network in the particular spectrum, and then connect to the the home network, basically the evolved packet core into the internet. So here we have what you call as a spectrum access system, which basically kind of provides this database of who is what kind of thing, and then provides the spectrum to each of these CBSDs. Meaning CBSD is nothing but e-node B. It's called CBRS device, where it's kind of akin to the e-node B. And this SAS, the spectrum access subsystem, is basically developed by WinForum, and and then it had this organization with FCC to get it approved and then tested and all that stuff. Now this SAS basically gets its information from FCC in terms of who are the registrants and all that information, the CBSTs and all that stuff. And at the same time, it also talks to something called ESC, and ESC means the environmental sensory capability. That's what ESC stands for. Now this ESC basically monitors the incumbents, the movement of the incumbents, the presence of the incumbents. So it monitors continuously the existing incumbents. So that information it shares with SAS. So SAS has a direct connection with ESC. It maintains this connectivity with ESC in a continuous basis. And then SAS also connects with other SASs. For example, SAS governs an area of it all depends on how they have kind of gathered, but multiple counties or county or whatever. So SAS kind of governs the CBSTs, okay, in a county or multiple counties, and then it connects with other SASs in the nation. Basically, that's the structure we have. Now, so this SAS can directly dock to a single CBST in terms of allocating its spectrum, understanding, what the environment CBST is kind of facing in terms of channel alignment. Okay, that information is kind of sent to SAS. So there are all these protocols are being enhanced on top of what 3GPP have to kind of provide this communication between your, CBRS E node B, I call it CBST for your understanding. Okay, so that and those protocols are kind of now put in place. Now you're seeing something called domain proxies. Basically, domain proxies are like an aggregation point. For example, if you have like bunch of CBSTs, together wants to talk to SAS, they can be combined together as an aggregator point. So there is something called a domain proxy, which can, which kind of, gets that information or talks to these CBSTs together into a SAS. You can imagine that a particular network can have like multiple CBSTs. They all have the same requirements. They can kind of go through a CBSTs rather than kind of having each one having an individual connection to SAS. So that's the network. That's the architecture that we have. So in regards to the power, right? So or the classes of CBSTs, you have like an indoor small cell class A, which kind of allows you to kind of transmit about 30 dBm, and class B is your regular macro network about 47 dBm. Okay, so you have like two classes of CBSTs, basically class A and class B. Okay, and they're all kind of basically from a functional overview point of view, you can have a small cell which is only kind of trying to kind of do things in a general authorized spectrum, general authorized access scenario, or a Paul auction license kind of scenario. Okay, or using one of these CBST classes. Okay, and they all talk to, or they're all kind of connected to SAS, and then SAS kind of have this connection with ESC, and then have this data upload and download with FCC in terms of the overall databases. That's the total situation. I mean, in terms of the architecture. So as we came together, one interesting and important thing is this CBRS spectrum, like I said, is between 3.5 gigahertz to 3.7, I said, and it's 150 megahertz. And everybody who is involved in this whole 3GPP structure, for LTE, they have defined different bands together, starting from band 1 to band, I don't know what, but band 42, is defined from 3.4 gigahertz to 3.6 gigahertz, and band 43 is defined from 3.6 to 3.8. But these bands were already kind of created, way before 2008. Bands were all created, and so that one could kind of communicate and then devise your receivers and your transmitters and so on and so forth. You can understand that whole radio aspect of the necessity of creating these bands. Now CBRS band is between 3.5. I mean, it's from 3.55 to 3.7. Like I said, it is right in the middle of band 42, and it ends at in the middle of band 43. So 3GPP, I mean, same companies, like I said, are involved in both 3GPP and CBRS. So the industry community went and then created a new band called 48, and that's what we have, and created the structure for the entire radio. Supports this channel bandwidths at an incremental level of 5 megahertz, 5, and it can have channel bandwidth 5, 10, 15, and 20 megahertz. Basically, that's what we have. And it also kind of created the entire the radio scheme, defined the emission limits for band 48. Now this is for LTE, for ECDE, okay, I mean ENDC, okay, for the 5G radio, it's called N48, band N48. So this has been completely kind of defined, that's one of the most important things. Okay, let me move on and give you, I mean, the story is long. Okay, I'm kind of, building the story up for you. The 3GPP was good enough to kind of create much more work for the, been working on this for the last 3 years. It created this band 48 intra-band carrier aggregation, those modes. Now downlink can be aggregated. We are talking about both bands up to 100 megahertz. Downlink peak rate rates can be, can be up to 16 gigabits per second. And step by step over multiple years, as the work happened, it has it's in 3GPP standards. I'm not talking about the CBRS. The 3GPP standards have now created, for example, in interband, 71 combinations of 2 different bands, 33 combinations of 3 different bands, and so on and so forth. In intraband combinations, that is like, if you have like bands, some other bands beyond this 3.5 plus, if you want to have a combination of band 48, they have created 147 such combinations, which are very important. Because if you want to do carrier aggregation, between bands beyond CBRS and then with the CBRS bands, so those bands have to be kind of defined. You have to kind of define the, the filters and all the information in regards to how the radio is operated, both downlink and uplink. So that has been done, and the same thing has been extended now with little more work, for 5G NR also. Okay, so that has been done. So there is a radio working group in that's what we have created. We created in CBRS Alliance a radio working group where these kind of issues are all kind of tackled, okay, over the course of last 3-4 years. And then there is a coexistence working group, and I'll give more, a little more detail. And then there's a network architecture group. These are the 3 different standards that have been put in place to kind of create the entire body of CBRS standards. Once again, it doesn't go against the 3GPP. It is kind of building on top of 3GPP to kind of make this all happen. Now, this slide here, I'm just talking about the ENDC band N48, and even that band is kind of clearly well defined right now for uplink, maximum bandwidth of 40 megahertz, different combinations. You can kind of see. I don't want to go into detail here. Downlink, you can kind of have up to 100 megahertz, different bands. How can they combine to kind of provide 100 megahertz bandwidth? So that's what is kind of created. Okay. Now, so that's what.
Sorry to interrupt, Ra. One question. So, the 3GPP technology is going to be used in these bands.
Right.
Is that going to be used as like a additive or standalone? Like, can you just rely on 3GPP technology in these bands, or
Yes.
do you need to have a cellular going on to aggregate these bands?
Yeah, good point. Okay, so for example, let's say if your device, okay, if you have a device which has not incorporated band 48, Rath, okay, you cannot go into a CBRS network and then use it. Huh? So clearly you cannot do it. So, but the thing is this one. So all the key players, okay, like you can call it all the people, Samsung, Qualcomm, and so on and so forth, including Intel. They have all devised. I mean, Intel till last year, it's not now. Even today, Intel is kind of working on the PC modems. All these companies have developed the band 48 to begin with, and all these companies, when they operate in CBRS, they use the 3GPP technologies basically. Okay, so that's what. So in CBRS is nothing but 3GPP technology with these additional enhancements to be able to kind of use spectrum access system to get spectrum allocated in the CBRS band and ensure carrier aggregation happens. That's what it is. Am I clear?
Yes. One follow-up question on that one. So assume like I have a device, PC or whatever, this N48 band capable. Do I also need to have the other regular cellular band and technology to be added together with this, or just having that N48 band itself with the technology I could be able to use it?
Good question. Yes, you can do you can do just the N48 CBRS band is just good enough.
Okay, thank you.
Okay, and the question is very relevant because basically what CBRS is looking into is kind of, help out this whole NPN, non-public private network kind of, deployment mode, neutral host mode, so that, private enterprises can kind of deploy a LTE kind of system, okay, just like a Wi-Fi kind of thing, and then have their devices, okay, whether it could be a phone or it could be a machine, which can kind of talk. So that doesn't have to kind of have support of other bands and other systems and all that stuff. It can basically talk to this CBRS network basically. But most often what you would see is that the N48 band will be aggregated with other things that you would have. For example, AT&T would have its devices which are supporting its own bands, correct? And it would add even N48 also, so that it would allow its device to kind of use the existing, existing bands that it is kind of supporting, plus the CBRS band, so that it can kind of aggregate with the N48. N48 kind of provides, like I said, up to 100 more megahertz of premium spectrum, correct? It kind of allows you to kind of do that. So AT&T and T-Mobile are kind of go that route. A private network, but kind of imagine in a practical sense, who will manufacture those devices which can only kind of use N48? Maybe there are, but I cannot think. Maybe it's a machine or some kind of internet, IoT element which wants to kind of do that.
So both are allowed, like standalone.
Both are allowed. To answer your question, both are.
Right, yeah.
Yes. Yeah. Okay. Okay. So some key important things that I just want to share with you, the way it's kind of like you understand, this is a little more complicated because of, okay, that you're using 3GPP system and then kind of doing CBRS on top, right? Shared spectrum. So, and then you have 3GPP, non-3GPP, like I already said, so there is a little bit of a complication. So but it's all being sorted out. So in order to understand, some key definitions are important. I'll kind of quickly go through it. I know for sure that I may not kind of do complete justice, but I'll kind of give you some idea to kind of explain, few things that have been done here. So what has been done is, to begin with, they have made some key definitions. One is called the coexistence group. So basically a group of CBSDs that are the E-node Ds in the CBRS world, abide by a common interference, management policy. They are called it as like the coexistence group. For example, all of, LTE is a one coexistence group. Okay. So that's what it is. Okay. And non-CBRS is like, WiMAX could be another one. So that's how they kind of define a coexistence group. And now within that, not within, but there's another important entity that's being kind of, defined, is called coexistence manager. Now this basically resides with SAS or a little bit outside SAS, and that decision was made later, but let's kind of assume for time being, it's kind of within, it's kind of next to SAS. Now this is a logical entity that's kind of, responsible for managing this coexistence between GAA users. There are like multiple GAA users, general authorized users. Okay. So it kind of manages this, meaning it manages between, what kind of spectrum that needs to be kind of allocated, what kind of communication that needs to happen. This is the entity that kind of does that whole thing. Now, beyond this one, right? So if you kind of go into this chart, so you have like, CBRS A coexistence group, which may be a LTE or a 3GPP, anything, something, or a 5G kind of a group, and it could be, non-CBRS groups. And now here, so within that, there are like other classifications. If somebody is using, some CBRS devices using a particular LTE TDD configuration versus another one, so they kind of have, different kind of, there is a divided classification there. But beyond that one, so you have the CBSDs, which kind of, belong to the same coexistence group, but they indicate that they can manage their own interference together. For example, a small network of users, a operator, which has like all this CBSDs, for example, in a given community, you have one network kind of have multiple CBSDs. They can all be part of this particular group, and that's called the interference coordination group. Now, it can so happen that this group can kind of have some kind of an alliance with another operator, and then kind of manage interference together. They can have some kind of agreement. So that's what is interference coordination group. And then below that, there is this group of CBSDs, which probably, and I'll give you a little more, just a little, into it. So they kind of have what you call as a common channel group. They are like almost like mutually exclusive within an ICG, meaning that they all have no interference with each other. They can kind of use the same spectrum. Okay, so that sort of thing. So that group is called common channel group. Basically, they are part of the same ICG requesting a common primary channel agreement, channel assignment. So this is a structure they have put in place. This is kind of vital to kind of understand how the spectrum is kind of allocated in CBRS. I'm just kind of checking on my time. I'll go for 10 more minutes or 15 more minutes as you want. Okay, but 10 more minutes, and then I can kind of wait for more questions. Okay.
Do you want to take a question
Yeah, sure.
what you so in the regular 3GPP 4G and 5G, there are mechanisms for the coordinations, the interference groups and everything already exist, right? So for this CBRS, why there is a need for additional separate the groups that you mentioned, ICG, CIG, and all kind of things are needed?
Yeah, sure. Okay, so you see, for example, if you have a network operator, okay, they have a very predefined spectrum in which they're kind of allocating, they allocate a spectrum to each network or each node B. Okay, this is something that they manage, how they do it. Okay, now here we are talking about multiple different networks using the same swath of spectrum, correct? You have,
I see. Okay.
Right. So, and then what we are saying is right now, how do we optimally make use of this spectrum by the operator? Okay, and between operators. This is the most important question. Okay, how can we kind of make? Okay, and that's what I want to, at least I have a lot more slides, but at least I wanted to kind of convey how this is done. Okay, that's an interesting part that you may appreciate it. Okay, I'll show you what I'm talking about. This will kind of clarify your question in detail. Okay, so okay, give me 1 second, I will do that. Okay, so the one of the most important thing is what you asked, Rath. So basically, the coexistence is the most important thing in question here. So coexistence between LTE 5G technologies and non-LTE and 5G technologies. How can we have the CBSs exist together? How the spectrum is allocated in the fair fashion, the most optimal fashion? How do we allocate the spectrum, and how can we ensure coexistence of these different categories of CBSDs? One are low power versus high power. Okay, so that's another thing. You're right. I mean, these kind of things are being done individually by the operators for their own networks. Yes, they are done. But when you're talking about all these different operators, how it is done. And the last important one is the coexistence of different networks. Okay, I mean, it could be a fledgling operator who is unnamed but have like multiple CBSDs and kind of wants to be in the game. Okay, versus AT&T who have like number of number of small and big networks of node Bs. So how do we ensure coexistence happens? How do we ensure fair allocation of spectrum? So that's the whole thing that CBRS Alliance kind of try to address by having these specifications. The release 1 dealt with some of these key aspects, okay, as to how to optimize LTE deployments. Now it is kind of working on LTE and then NR in release 3 and release 4. Okay, release 3 is being done, like I said. Okay, defines, I mean, naturally you can imagine, LTE, phase synchronization requirements, it kind of look into all that, and configuration requirements, because, in LTE and then 5G, you have all this, For TDD, you have these different configurations. What kind of configuration that you need to have, what kind of rules you need to have in terms of bandwidth allocation, what are the protocol enhancement that you need to do between eNode B, which is kind of CBSD in our case, to SAS. Okay, and because how does SAS knows that CBSD is not interfering with another another CBSD? So these are the kind of things that it had to deal with in release 1, and it has put a lot more meat into a lot more specificity into who assigns what in terms of what entities they are. So that is all being done. Basically, here the first level of work was done. The second level of work was like clearly assign the entities, name them, and then provide all this, rules in place. That's what the specification release 2 was done. A little more than what I'm saying here, just for the, for our conversation. So that's what specification release 2 has been done. Has kind of looked into. So, and let me give you an idea about, what I'm talking about. I'm talking in some abstract terms right now, but I'll kind of give you something. So they had to resort to something like a graph theory to kind of define a way to address this spectrum in question. 150 megahertz of spectrum, you have like several CBSDs, several networks we talked about, but CBRS Alliance kind of only looked into only one coexistence group, that is, 3GPP, LTE, or to begin with LTE, and later on NR. Now, what it has done is, I just want to give you this as a key stepping stone here. What it has done is, it has created all these different CBSDs as vertices in this graph theory, okay, in this graph mechanism. And so there would be a what do you call a edge, okay, basically by a single line if a particular CBSD interferes with another CBSD. For example, if you can see my my stylus here, right? And if there is interference between this CBSD to this CBSD, you have an edge. So it would kind of create a a graph like this. Okay, for example, this CBSD doesn't interfere with this CBSD. Otherwise, there would be another edge between these two. So it would create something like this. Okay, something like a graph like this, who is interfering with what, and then have an edge between each other. Now, let's say there are other CBSDs, right? This CBSD doesn't interfere with any of these things. So you kind of have a connected set like this, okay? So basically, this is one group of CBSDs in a connected fashion. This is another CBSDs, connected in, this kind of, a connected fashion here. So you have 4 different networks which are isolated. For example, if you have 150 megahertz of spectrum, that needs to be allocated between these CBSDs, and the same 150 can be given to this one single CBSD. You agree? You can kind of see what the whole idea is here. Like, this is totally exclusive of this network, and this network is exclusive of these 2 other networks. So they are kind of looking into ways to kind of allocate the maximum amount of spectrum to each of the CBSDs. Now let me kind of do a little more thing here. One more enhancement. So for example, now what they want to see is, they want to kind of create the minimum number of colors that they can kind of have in this network. For example, these circles right here are not connected, right? The circles are not connected to each other. So they can probably have not probably, they will have only one single color. And like these triangles, they are not connected to each other. You can see they can have, these triangles are exclusive of any other thing. So basically, they have like one other color, and these hexagons, they are like, once again, exclusive. So basically 150 megahertz of spectrum, okay, is kind of allocated between these CBSDs, and these circles kind of form a closed group. Okay, these circles form a closed group. They don't interfere with each other. Therefore, they can kind of be allocated the same spectrum. Okay, so to speak, within this. So for example, 150 megahertz, there are how many colors here? You see, there are only 3 colors, right? Red, blue, and an yellow. 150 megahertz of spectrum is given, is allocated to 3 groups here. 50 megahertz is what these circles receive, and 50 for these triangles and 50 for these hexagons. So you can see you can kind of clearly take a view like 150 divided by the number of CBSDs. You will end up with a very little spectrum. By doing this, you are kind of trying to kind of maximize the amount of spectrum that you can kind of get. And there's a little more to this whole graph theory as to see how to kind of allocate more and more amount of spectrum. For example, this guy has gotten, this spectrum, CBSD got 50 megahertz of spectrum, and it can probably get some more spectrum, okay, because it's not interfering with this. There's a little more layered work that you can kind of do. So every CBSD is kind of, I'm just kind of presenting only the fundamentals here. So more work has been done to kind of see how the spectrum can be maximized. That's how the assignment has been done. And all this work is being done by the domain, not by the SAS, the coexistence manager. These are the algorithms that are kind of put in place. Now, the thing that I wanted to mention is, therefore you can kind of see the necessity of having a CXM to kind of do this. And another important necessity is, how do we know that the CBSD is not interfering with this triangle, for example? For that, you need to be able to kind of measure the transmit power of each of these, the interference boundaries of each of these CBSDs. That information is continuously monitored, just like in a small cell it is done, like, the network listen kind of a mode that you have in small cells. And also, you have this kind of a scheme in every phone and every mobile phone. So that scheme is kind of put together. These measurements are kind of continuously transmitted to the SAS. Okay. So this is the basis of CBRS, so to speak. Okay. I think I have come to one important milestone, although I wanted to share more here. The time is 6:20. I know that I cannot go too beyond, beyond a point, but I'm willing to go for a few more minutes and kind of give you, the targeted network deployment scenarios. But if you have any question here, I will kind of take it, huh?
Okay, we're good.
Yeah, you can go. Yeah,
Yeah,
we can.
okay.
If time permits, we can ask.
Okay.
Questions. Yeah.
All right. Very good. Okay. So now I'll go back here, and then you see, I think right here itself is good. So now in this situation, like you see, it's all a TDD kind of network here. It's not an FDD kind of network. I mean, sorry, not network, but configuration. That's what been adopted or used, because everything is contiguous. Okay, so that the best possible way to kind of deal with it is kind of use the TDD scheme. So now, if you want to have optimal use, I think every one of the CBSDs which are serving the end users use the same TDD configuration. Okay, so so they use the same TDD configuration, and SAS allows them to use whatever the CBSDs so choose. So you can imagine, all the CBSDs are probably belong to a particular network operator, or maybe a couple of network operators who are kind of have some kind of an, some kind of an agreement. Now they all use one single, like I said, TDD configuration, the uplink and downlink configuration. You have number of them. I don't quite remember exactly how many. Now, for example, let's say if there is a little bit of a difference of opinion as to how they are using, okay, the CBSDs wants to kind of use more uplink versus downlink, and some wants to use more downlink versus uplink. So then there is some kind of a clash, and the SAS can resolve this clash by polling, okay, and asking for them to kind of choose what's the best they want to kind of do it. But it is something, what they do is, if there is a real clash, then the CBRS, the SAS is going to do something like this. It kind of forces them to kind of use one of these configurations. You can see here, uplink and downlink are 4:4, or or 2:6. So this is kind of the set scheme that CBRS Alliance is using it. Now it wants to do, I mean, I'm talking to you folks, maybe you can kind of join CBRS Alliance and kind of, look for more innovations. Okay, there is plenty of ground for new innovations here, really. So they are now looking to kind of see how different CBSDs can use different configurations, it's up to them. But if you have to provide a way that you don't kind of interfere with each other, right? You have to ensure that there is no harm done to others if you want to use something else. But right now, it's a basic scheme. So use whatever you can if there is no problem. But if you want to use something of your choice, then CBRS Alliance is going to define, these two schemes. And then if there is a difference there, it's going to use some kind of a polling to kind of define what it is. I hope you kind of see this, what's happening here. Okay. Now, everything is good, and then you may be wondering, hey, where this is going to be really used, how best this can be used, what is the work that has gone. So while this radio work and then coexistence work is going on, and a lot of good work has happened over the last 3 years in terms of defining these schemes to kind of allocate spectrum, the protocols and everything in place. On parallelly, they were kind of looking into what kind of architecture that we can kind of put in place, because for that, the most important thing is where this is whole targeted. This is targeted to neutral host networks, and I'm sure some of you are very aware that this is the kind of mode that you want in a private network. So there's a good amount of work being done in Multifier Alliance when they bought this whole unlicensed spectrum used for LTE, if you remember that, and the work still continues in Multifier Alliance. But basically, that was the kickoff point, or that was the baseline, that CBRS Alliance looked into, and then defined all the procedures to kind of all the means to kind of define the architecture for neutral host network. And another important thing is it looked into how to kind of define CBRS band for multi-service operators like, I forget the names, Cable Labs, I think, or Charter, and one of these, not your wireless operators, but people who are into kind of providing wired services and all. They can kind of how they can kind of use these kind of services, multi-services operators, mobile network operators. 3 different cases. So it looked into those network architectures. So specification 1 dealt with NHN, neutral host network. Specification 2, with a combination of private network and then NHN and fixed network use cases, and so on and so forth. They divided the work this way. Right now, 3 specifications completely done and released, and then it's going for the 4th one. So, so what is that I want to share in the last few minutes I have is, so neutral host network is the most attractive and the most, I should say, is a killer use case that CBRS kind of, looked into, basically. Okay, so, what that entails, if I can have to tell you, is that any private party or public party can kind of deploy a CBRS kind of network, okay, and ensure that it can use all for itself, or make that neutral host network be shared to other network providers. So basically, NHN, as it stands for, the definition stands for, is a network basically operated by an NH operator, who can be an independent entity, or it can be a already existing network operator, but where the resources can be shared by multiple. So this is the basic architecture or basic use case and architecture that CBRS exploited heavily at this point of time, and that's the reason of so much interest in the industry community. I'm talking about not the traditional, but the non-traditional new entrants who kind of came into this whole game. So just to give you an idea, so basically a CBRS network operator kind of creates his own network, something like this, and then can have business agreements with different service providers, and each service provider has their own way of kind of dealing with their users who or subscribers who have this SIM modules and others, how to authenticate and all that stuff. Those procedures are all well established, that. So but there is a way to kind of if you authenticate with some service, a particular service provider, there may be there is a CBRS network operator has to still authenticate the subscriber as well. So the procedures have been established. This is your ground line scenario. So from here, if time permitted, I would have gone into more detail. But so basically, you have this simple service provider case who wants to deploy its own CBRS network and then have roaming agreements, for example, with other MSOs to kind of use their CBRS network, basically. And then, of course, its subscribers can use the CBRS network, and for them, they will do anything. But with others, they will probably have some kind of, this is your, for other operators, they will have some kind of agreements, So that's the, that's a mode of operand. That's the first one, a very, very simple one. So the most important one is this neutral host network, where you have the CBRS network, and then, you are in, it can be an independent agency completely, have business agreements with multiple network operators, MNO and MSO. They have their own CBRSs and then kind of operate it. And a complete architecture is kind of defined, it's a little beyond, it's kind of making use of all the elements you have in 3GPP, everything, all the interfaces that you have, the S interface and STA interface and the non-3GPP interfaces you have. It uses all these things and ensures, the implementation of these network architectures. I think we we have come to the end of the thing. I think if I start anything new right now, I'll be kind of taking beyond my time, I think.
Yeah, I think it's a good idea to. Yeah, there is one question in the Q&A, if you don't mind. It's a long
Yeah.
question.
Yeah.
Uh,
Please,
mm,
if you
yeah.
can kindly read
So,
it.
okay,
I
it's a
cannot
long
see.
question. Yeah, okay. Do you think the SAS federated function will spread to other frequency bands that may become available in a similar way to CBRS? For example, AFC in 6 gigahertz could
Yeah.
benefit from an optional
Hmm.
SAS rather than to have an enterprise deploy servers to perform the same function.
So, I think yours is probably a futuristic kind of a question. Looks like it. Okay. At this point, so I think the gentleman, I think, probably has some idea about what, things that have been kind of happening on the background, I think. So right now, what's happening is CBRS. This is 3.55 to 3.7. And CBRS Alliance is kind of looking into other spectrum in 6 gigahertz and then something below 3.5, and how they can kind of, enhance or evolve the whole SAS to kind of, club these kind of things. This work, there is no agreement between anybody at this point of time. Everybody is kind of working on their own. They're kind of looking to kind of come together. I cannot say whether it is possible or not, honestly, because not work, practically speaking, SAS right now is only dedicated to 3.5 to 3.7. Okay. So it's only defined for 3.5 to 3.7. It doesn't do anything with any other band, okay, beyond 3.5. But if you're asking me the future possibility, yes, definitely that's possible. And I mean, from my point of view, it's possible. But we are talking, well before our time, okay, on this whole thing.
All right. Thank you, Rao. It is, we are fortunate to listen from the vice chairman of the CBRS Alliance about the CBRS technology. Thank you very much for your time and, the willingness to come to Oregon chapter, ComSoc, to give this wonderful talk. Thank you very much, Rao.
Thank you very much.
Okay, and thank you, and have a good day, everybody. And thank you also from Oregon chapter for your presentation today, Dr. Rao.
Yeah. Once again, thank you, for giving me the opportunity. Thank you for, and I'm very glad to kind of, be connected with all of you this evening.